Hi everyone, my name is Pradyumn Kejriwal and today we will discuss the solution to the 12th problem from the CP sheet by TLE Eliminators under the rating of 1400. So let's begin. As you can see, I have my sheet right here and I have this problem. I can open it. It is called schedule management. There are n workers and m tasks. The workers are numbered from 1 to n. Each task I has a value ai. The worker who is proficient in this task. Every task should have a worker assigned to it. If a worker is proficient in the task, they complete in 1 hour. Otherwise, it takes them 2 hours to complete. The worker works in parallel, independently of each other. Each worker can only work on one task at once. Assign the workers to all the tasks in such a way that the tasks are completed as early as possible. The work starts at time 0. What is the minimum time all tasks can be completed by? Okay, so here what we have is that we have basically m tasks and n workers to complete them. Okay, and we have to assign these tasks to these workers, or basically the workers to the tasks. All right, and they can work in parallel, right? But at one time each worker can only perform one task. Okay, and what they've also given us is that for every task I we have a number ai, which is the index of the worker who is good in this task. Okay, so if a worker who is good in a task does that task, then it will take him 1 hour to do it because he is good, right? And if anyone else does it, then they will take 2 hours to do it because they are not good in that task. Okay, so we have to assign these tasks, or we have to assign the workers the tasks in such a way that the total time, like the final time to taken to do all the tasks, is minimized. Okay, so for example, we have the samples 1 2 1 2, let's say. So we have four tasks right here, 4 tasks and 2 persons, and we have 1 2 1 2. That means the first person is good in tasks 1 and 3, these 2 tasks, and the second person is good in tasks these 2, right? And so what is the minimum time that we can achieve? So the answer here is 2. Like in 2 hours we can do all of this. How? We can simply assign the first person these 2 tasks. Okay, this pen is all right. So these 2 tasks to the first person, and second person these 2 tasks. Okay, and they both will complete each task in 1 hour because they are both good in that task. Like since person 1 is good in this task, it will take 1 hour, and also is good in this task, it also take him 1 hour, right? And since person 2 is good in these 2 tasks, it will take him 1 hour each. So in total 2 hours for the first person and 2 hours for the second person. So basically in total 2 hours time has been taken to do all the 4 of these tasks, right? So the answer is 2. Now one more test case I'll show you. Like let's say we have the test case 1 2 2 2 2, right? So basically there are 4 tasks in which 2 is good, the person 2, and 1 task in which the person 1 is good, and n here is 2. We have only 2 workers. All right, so in this case what the answer would be is I think it should be equal to 3. Okay, and how I got 3? First of all, this is equal to 2. Okay, yeah, so the answer can be 3. And how? We can give the person 1 this task and also this task. Okay, he'll complete this task in 1 hour and this task in 2 hours, right? So in 3 hours this person can do all his tasks, and we can just assign these 3 tasks to the person 2, so in 1 hour each. So in total 3 hours the person 2 can also do these 3 tasks. So in parallel they take only 3 hours to do, right? So the answer is 3 for this test case. All right, and similarly you can just check out the other test cases and check their answer. And the constraints here are that n and m are up to 2e5. Alright, n is less than equal to m and it is less than equal to 2e5. So we can only do like O of n or O of m, or maybe log factor somewhere like n log n or something. Like we can't do O of n square, because in 1 second we can only do 10 to the power operations, right, in a single test. So n square doesn't work, but these will work. So you have to think of these, right? So you can just pause the video now and try the problem by yourself if you want. Okay, so I'm assuming that you have tried the problem by yourself and know a solution now. Alright, so the first thing that is pretty clear in this problem is that it is somewhat monotonic. Like, see, first hint is here in the problem. They have asked the minimum time, right? Minimum time. So whenever you see words like minimum, maximum to compute, we can like think about the monotonicity in the problem. Like here, what I can say is that, let's say that for a certain input, like let's say I have the input n and m and all the numbers from a1, a2 up to am. So for this input, if I know that I am able to uh, do all these tasks in, let's say, 5 hours, right? Then definitely, if I am given 6 hours, then also I can do it, obviously, right? If I can do it in 5 hours, I can do it in 6 hours as well, because 6 hours is just extra time. I can just spend the last 1 hour doing nothing, right? So I can definitely complete anything I can do in 5 hours in 6 hours, right? So like in general, if you say that if you are able to complete these tasks in t hours of time, in t hours, if you can complete, then definitely any value greater than t also you can complete in that time, right? And let's say that the minimum value of t, that is the answer to this problem, is some t naught. Okay, so it is the minimum amount of time in which you can complete. So basically for any t which is less than t naught, you can't complete it, right? And for t naught you can complete, for t less than t naught you can't complete, for t naught you can complete. And since I told you that if you can do it for t naught, you can do it for anything more also. So for t greater than t naught also you can do it. So basically, if you just look at the function, like if you just answer the question that can I complete all tasks in time t. Okay, so if you just try to change this t and answer these questions for all values of t, you will see that it follows a monotonic pattern. Like for initial some hours of time, like let's say for 0, 1, 2 up to t naught minus 1, you will see that you can't complete it. So false, right? So no, basically. And from t naught onwards, you can complete that. T naught plus 1, right? So basically you can, if you want to find out the minimum value of t naught, like the value of t naught, basically the first position at which the true appears, you can simply apply binary search to your rescue, right? So like you have an active range, and then you will check the middle value, that can you do it in this much time. If it is false, then you will check the higher values, that is where active range will become that. And if it is true, like you can solve it, let's say you are here, then you will check the lower range now, right? That's what BS is, binary search on answer, right? But the main thing here now is how do we make the predicate function, that is how can we answer this question. given a time t, can I do it, right? Essentially. So how do we write the predicate function? Okay, so for this, let's see a test case. All right, like here we had this test case, right? 1 2 2 2 2. Okay, and let's say that we're checking for t equal to 3. Like, can we do it in 3 hours? Okay, so basically we have to assign some tasks to both 1 and 2. Like, I'll just index these tasks. Okay, so this is task 1, task 2, task 3, task 4, and task 5. So I have 5 tasks and I have 2 persons, person 1 and person 2, right? And I have 3 hours to complete. Okay, so one thing to notice, like, okay, basically what's our aim? We have to assign all of these tasks to the persons. Like, I have to assign tasks to this person 1 and also this person 2, and I have to check that can we actually complete all of them in under 3 hours, right? So basically when I'm assigning the tasks for person 1, obviously I'll assign those which he is good in, right? Like, I'll assign those first. Like, since he is good in the task 1, right? So I'll assign the task 1 to him. Okay, but now he is not good anymore in any other tasks, right? So now, like, since he has, okay, in doing this task, he spent 1 hour, right? Because he's good in that task, but he still has 2 hours left, right? Out of 3. So he can actually do one more task in which he is not good, right? So I will assign one more task to him even though he is not good in that, right? And for this 2, like, okay, for this 2 we can simply assign all 3 tasks in which it is good, right? So 3, 4, and 5, task 3, 4, and 5, this 2 is good at, right? So basically the main strategy here is that we can greedily apply, like, we can greedily just choose those tasks in which the person I is good. Like, if we are considering that what do we give to person I, okay, then first give all those tasks to him in which he is good. Okay, in which he is good, he will do them first, right? And if he still has extra time left after doing all of those, okay, then he can do the other tasks, right? So essentially you can figure out that in the given amount of time, how many tasks at maximum can he do, number of tasks that he can do in this much time. And if you just calculate that for all the workers and add them up, then it should be at least m, right? Like, basically here what I have done is, okay, first of all, I have assigned this person, I have assigned this good task to this person 1, and it will take 1 hour. So he has one more hour, he has 2 more hours remaining. So in 2 more hours he can do one more task remaining. So basically I can just say that there is one extra task remaining, one extra task he can do if he wants, like, if I want, right? And for this 2 has 4 tasks that he is good at, so I will give 3 of them, right? And the remaining one I can give to the extra, right? So that's the entire strategy here, that just give the tasks in which the people are good at to do first, and if they still have more time remaining, then just give them more tasks if necessary, right? Or, like, to implement this logic, what we can do is we can keep track for each person that how many total tasks can it do. Okay, so let's just take one more example to understand this. Like, let's say I have 1 1 1 2 2 3. Okay, and let's say that I am checking for t equal to 2, or let's say t equal to 3. All right, so for person 1, person 2, and person 3, I'll figure out that how many tasks can they do. Okay, so person 1 has 3 tasks that he's good at, right? And there are only 3 seconds, so he can do 3 tasks in this 3 seconds because he'll do those in which he is good, right? Then person 2 has 2 tasks in which he is good, so he'll do those 2 definitely, plus like now he has how many? He has 1 second, 1 hour remaining. He has 1 hour remaining, right? So he can't do anything in that. Like since he just has 1 hour, but he cannot do a task in which he is not good in just 1 hour. Like it will take 2 more hours to do it, right? So he will just do these 2 in which he is good. So the person 2 can complete 2 tasks, right? And person 3, what about that? So person 3 has 1 task in which he is good, so he will do that one. Then he is remaining with 2 hours, right? 3 minus 1, 2 hours, and in that he can do one more task in which he is not good, right? So basically the person 1 can do 3 tasks in this 3 seconds, person 2 can do 2 tasks, and person 3 can do 2 tasks as well. So total we have 7 tasks that can be done in this time frame of 3 seconds, right? And since the total tasks that we have are just 6, we can say that since 7 is greater than or equal to 6, I can say that it is possible to do it in t equal to 3 hours, right? So I'll return true for this case. All right, so in general, if I have that for the ith person, let's say for time t equal to t naught we are checking, okay, and for the ith person he is good in fi tasks, okay. So basically the frequency of I in this input array is fi. Like basically this ith person is good in these many tasks, fi amount of tasks. This is a number, okay, the frequency. So what will I do if fi is less than or equal to t, or let's just say fi is, if it is greater than t, then that means he can't complete all the tasks in this much time in which he is good at. So he will only be able to do like t amount of tasks. See, what I'm doing here is for the ith person, I'm calculating that how many tasks can he do in t naught seconds, right? So if the fi, that means the number of tasks in which he is good, is greater than t naught, that means there are too many tasks that he is good at, but the time is too less. Then he will be able to do t naught amount of tasks, because each task takes 1 hour, right? And he has t naught hours, so he will take t naught hours, t naught, yeah, he can complete t naught tasks to do it, right? And if fi is less than or equal to t naught, that means the number of tasks that he is good at is less than or equal to the total amount of time that he has. Then that means he has some spare time, right? So first what he'll do, he will just do fi tasks that he's good at, right? Plus he can do some extra tasks. So how many can he do? Basically he has t naught minus fi remaining hours, right? And since each task in which he is not good at takes 2 hours, that's why he can do divide by 2. Like if he has t naught minus fi amount of hours, then he can do this much amount of extra tasks, right? So we can compute this value for every person, which will give us the maximum amount of tasks that we can do in t naught amount of time. And if that is at least m greater than or equal to m, that is, if it is at least the number of tasks that we have, then we will just say that yes, it is possible to solve, right? And that's the entire logic of this problem. So I'll just show the code now. In the code, in the main function, I have this just fast IO and test cases while t minus minus solve, right? And in solve function, I have int nm, c in nm, and I have this global frequency vector, right? So I'm just assigning it to n size and all zeros initially, right? And I'm taking the input, and I just need the frequency array, right? So I'm just taking the array input, and I am incrementing the frequency fr of 10 minus 1 plus plus. And why minus 1? Because I am doing it in zero indexing. Like this problem has one indexed, but I am doing it in zero indexing. Then what I'll just do is while low, like binary search basically, and if check, then high equal to mid, and like basically if we can do it in mid amount of time, then high equals to mid, and if we can't, then low equals to mid plus 1, right? And my low is equal to 0. Actually I can keep it as 1 as well, but 0 is pretty safe. And high is 2m. And why 2m? Because in the worst case, like if we just choose the worst possibility, that we give all tasks to one person and he is not good at them, then there are m tasks and he will take 2 hours for all of them. So in the worst case, we have 2 into m hours that it will take, right? So it is a very loose bound, but it works, right? So yeah, low equal to 0, high equal to this, and we just binary search by check function. How does check function work? Check function counts the maximum possible amount of tasks that we can do in t hours, right? So I loop over all the workers. Now if t is less than frequency of I, that means the time is too less, then he can only do t amount of tasks in t hours, right? And if the time is sufficient and he has remaining time left, then first he'll do the fr of I tasks, the frequency of I mean all the tasks in which he is good, plus by the remaining time he will do by 2 of that, and this is GIF by default in C++, right? And return max possible greater than equal to m. So if max possible is greater than equal to m, then return true, otherwise return false, right? And the TC of this approach would just be like here it takes log m because the bounds are 0 and 2m, so it will take log m to the base 2 iterations, and O of n to check. Like this loop takes O of n time, as you can see, right? And also creating this frequency array takes O of m time. So finally it is just O of n log m plus m, right? So log m into n here and m here, so n log m plus m. And space complexity, like we are just storing this frequency array, right, which is of size n, as you can see, right? Space complexity is O of n, okay? That's why it is O of n, right? So I hope you understood this problem. I'll see you guys in the next video.